Next component is an accumulator, a hydraulic accumulator. An accumulator, essentially, this is going to be attached to a hydraulic system, a cylinder, and you'll have dry nitrogen or some type of gas within this chamber, and it's filled up, and the hydraulic actually will, when you have a spike hydraulically, you have X amount of pounds filling up in this chamber, and this will be kind of like a little balloon. Okay, and like when you push on a balloon, it's going to have the same thing when you have a spike in hydraulics or something. This is consistent pressure, then you spike it, so it's going to push against that balloon. It's going to cushion that. And that's essentially how this works. But our first question, a bladder type accumulator, is gas chamber is filled until designed to cushion and decrease hydraulic pressure spikes. That's exactly what we just explained. It will decrease spikes. Next, an accumulator and an attenuator in certain applications will function somewhat the same result. That's true. You can have an accumulator and an attenuator, which is essentially a hydraulic muffler. An attenuator is a can. You have pressure spike, hydraulic pressure spikes coming in, and you have a chamber in there which actually absorbs, you have enough oil in there to absorb some of the spikes, so to speak, some of the hydraulic pulse. And an accumulator does the same thing. You have hydraulic coming in, and that will cushion. That'll dampen some of the spikes like that. Okay, the next question. Okay, concerning the physics of pressure within the gas chamber, pressure is irrelevant. That's false. Because, okay, if you have low pressure within this chamber, you have X amount of pressure, hydraulic pressure here. If you have low pressure in here, it's going to fill up more of this chamber, and you will not have the cushion or the pressure in here to correctly dampen the hydraulic spikes. Now the next question, an accumulator can also be considered as a hydraulic pressure reservoir, such as a capacitor in an electrical application. That's true. This can actually have a little bit of, you've got this area is pressurized with oil, and you've got pressure here. So anytime you have a pressure droop, so to speak, you have pressure demand elsewhere in the hydraulic circuit, it's going to droop down. So this is going to move out due to the fixed pressure in here, and supply just a little bit of oil to assist that additional hydraulic circuit. So that is true. The last question concerning this particular component, an accumulator is a flow-through device. No, it is not. It is strictly hydraulic on one end of it, and you've got the sealed chamber and a charge valve right here. That's where you charge this particular portion of the chamber with the gas, and you just have this one inlet. There is no pass-through. That is all on that particular component.